You have never touched anything, not once. Not your coffee cup this morning, not the phone in your hand right now, not another person's skin, not the ground beneath your feet. Not one single time in your entire life have you made physical contact with anything in the external world. And the feeling of touch you're experiencing right now, that's completely real. Both things are true, simultaneously. And figuring out how that's possible will change the way you understand matter, force, perception, and what you actually are. Let's start with something you're probably doing right now, sitting. You're sitting on something, a chair, a couch, a floor, and it feels solid. It feels like support. It feels like contact between your body and a surface that's holding you up. Here's what's actually there. The chair is made of atoms, so are you. And an atom is almost entirely empty space. Take a hydrogen atom, the simplest one. If you scale the nucleus up to the size of a marble and place it in the center of a football stadium, the electron would be somewhere in the outer seats. Everything between the marble and the outer seats, the field, the stands, most of the stadium, empty, nothing there. And atoms are the building blocks of everything, the chair, your body, the entire physical world. So you're a collection of nearly empty structures. The chair is a collection of nearly empty structures. And yet you don't fall through it. Something is holding you up. That something is not what most people think. It's not that the atoms are packed so tightly they block each other. They're not. There's almost nothing there to block anything. What's actually happening is this. Atoms have electrons orbiting them, and electrons carry negative charge. When your electron clouds get close to the chair's electron clouds, they repel each other, electromagnetically, violently. Before any atom ever gets near another atom, solidity isn't a property of matter. It's a property of electromagnetic repulsion between electron clouds. The hardness of a diamond, electromagnetic repulsion, very tightly arranged. The softness of a pillow, electromagnetic repulsion, loosely arranged. Different textures, different densities, wildly different fields. Same fundamental mechanism. Electrons refusing to share space with other electrons because they carry the same charge, and like charges push each other away. You're not sitting on the chair, you're hovering above it, electromagnetically, and the hovering feels like sitting. Now I want to introduce you to the force that's actually running your entire physical life, because most people give gravity credit for everything, and gravity doesn't deserve it. Gravity shaped the universe. It holds the planets in orbit. It's real and it's important. But in your daily experience, in every sensation you've ever had, every texture you've felt, every temperature you've detected, every image you've ever seen, gravity is almost irrelevant. The force doing the actual work is electromagnetism. Think about what touch is. Your fingertips press against something. Nerve endings in your skin detect the deformation of tissue. Signals travel through neurons, electrochemical signals, which are electromagnetic. The brain receives those signals and constructs the sensation you experience as pressure, texture, hardness, softness. Every step of that chain, electromagnetic. What about warmth? You hold your hands near a fire. Infrared photons, which are just electromagnetic radiation at a particular frequency, hit your skin and transfer energy to the molecules there. You feel heat, electromagnetic. Sight. Photons, particles of light, which are the carriers of the electromagnetic force, enter your eye, hit photoreceptor cells in the retina, trigger a chain of electrochemical reactions. You see, electromagnetic. Sound is slightly different. That one starts with pressure waves in air. But the detection of those waves inside your cochlea by tiny hair cells that bend and generate electrical signals, electromagnetic again. One force running almost everything you experience. The force that stops your hand from passing through a wall is the same fundamental force that lets you see the wall. The same force that lets you feel it is the same force carrying the light from it to your eyes. And the carrier of this force, the particle that mediates electromagnetism, is the photon. Not just visible light, all of it. Radio waves, microwaves, infrared, ultraviolet, X-rays, all photons, all electromagnetic, all the same force at different frequencies doing different things. You feel things because photons are being exchanged between electron clouds. You never needed to make physical contact. The force reached across the gap and did everything. The gap never closed. It didn't need to. Now here's where it gets genuinely strange. I want to tell you what's actually happening at the quantum level when you touch something, because it's not what classical physics would suggest. In quantum electrodynamics, which is the theory I spent a significant part of my career developing, and which is the most precisely tested theory in all of physics, electromagnetic forces are not transmitted through some invisible field that permeates space. They're transmitted by particles, specifically by what we call virtual photons. When two electrons repel each other, they're exchanging virtual photons, throwing them back and forth between each other at extraordinary speed. Each exchange carries momentum. The momentum pushes the electrons apart. That's the repulsion. The word virtual needs unpacking. These are not photons you could catch with a detector. They exist only within the quantum mechanical transaction between particles. They borrow energy from the vacuum, which the Heisenberg Uncertainty Principle permits for short enough time intervals, carry the force between particles, and vanish. They're real in their effects, invisible in every other sense. So touch, the sensation of touching something, is an exchange of virtual photons between your electron clouds and another object's electron clouds, happening trillions of times per second, across a gap that never closes. The collision you felt was never a collision. It was a quantum conversation. What you call touching something is your atoms and their atoms talking to each other across empty space. And the speed and intensity of the conversation generates what your nervous system interprets as contact, pressure, texture. There is no moment of contact. There's only the force and the feeling it creates. And now, here's where quantum mechanics makes the whole thing stranger still. You might be tempted to think, okay, so the atoms don't touch, but there's a definite point where my electron cloud ends and the chair's electron cloud begins. A sharp boundary, a precise gap. That would at least make intuitive sense. There isn't one. Heisenberg's uncertainty principle tells us that you cannot know both the position and the momentum of a particle with perfect precision simultaneously. Not because our instruments aren't good enough, because the universe doesn't allow it. Position and momentum are fundamentally linked. Pinning down one blurs the other. This isn't a measurement problem, it's a feature of reality, which means electrons don't have exact locations. They're not little balls sitting at specific points in space. They exist as probability clouds, mathematical distributions that describe where the electron is likely to be found when you look. But before you look, before any measurement happens, the electron is genuinely smeared across a region of space. So when your fingertips meet, it's two probability clouds overlapping, two smeared, uncertain, fuzzy quantum entities negotiating a boundary that isn't sharp. There's no clean edge to either of them. And here's the part that should break your intuition completely. There is a small but non-zero probability that an electron from your finger could tunnel straight through the other electron cloud and appear on the other side. Quantum tunneling. The particle doesn't go over the barrier, it goes through it, because at the quantum level, barrier doesn't mean what you think it means. It means region of high probability of repulsion, not impenetrable wall. Tunneling actually happens. It's not a theoretical curiosity. The transistors in your computer chips operate partly through quantum tunneling. Engineers design around it. In the core of the sun, protons tunnel through the electromagnetic barrier between them to fuse together. That's how the sun generates energy, and without tunneling, it couldn't. Certain chemical reactions in biological cells proceed via quantum tunneling, possibly including reactions in your own neurons, right now, as you think about this. The boundary between touching and not touching is quantum mechanical, fuzzy, probabilistic, occasionally porous. There's one more layer I need to add, and most science communicators skip it, so I want to make sure we get there. When I described electromagnetic repulsion as the reason you don't fall through the floor, that's true and it's part of the answer, but it's not the whole answer. There's a second, deeper reason matter has volume, a reason that has nothing to do with force. It's called the Pauli Exclusion Principle. In quantum mechanics, particles come in two fundamental types, bosons and fermions. Electrons are fermions. So are protons and neutrons, the particles that make up atomic nuclei. And there's a rule that applies to all fermions. No two identical fermions can occupy the same quantum state simultaneously. This is not a force. Nothing is pushing them apart. It's more fundamental than that. It's a rule about the nature of quantum identity itself. Two electrons simply cannot be in the same place with the same properties at the same time. The universe doesn't permit it. When two atoms are pushed together, their electrons would have to share quantum states. The Pauli Exclusion Principle forbids this. The atoms resist compression, not just because of electromagnetic repulsion, but because the universe is enforcing a rule about quantum identity that has no classical equivalent. Without the Pauli Exclusion Principle, atoms could be compressed indefinitely. There would be no such thing as stable matter. Everything would collapse. Solidity, the entire concept of solid matter, depends on a quantum mechanical rule about the distinctness of particles. And the stakes of this principle go far beyond your chair. When a star like our sun runs out of fuel, it collapses under its own gravity. What stops it from collapsing all the way? Electron degeneracy pressure, the Pauli exclusion principle, refusing to let electrons share quantum states. The result is a white dwarf, extraordinarily dense but stable. When gravity is strong enough to overcome even that, in more massive stars, the electrons and protons are forced together into neutrons, and neutron degeneracy pressure takes over. That's a neutron star. When even that fails, when gravity is strong enough to overcome the Pauli exclusion principle for neutrons, nothing stops the collapse. That's a black hole. The floor beneath your feet is held up in part by the same quantum rule that determines whether a dead star becomes a white dwarf, a neutron star, or a black hole. You're sitting on quantum identity, and it's holding. Now I want to make a turn that the physics earns. If you have never touched anything, if every sensation of contact you've ever had was generated by electromagnetic forces acting across a gap, then where does the self end? Your skin feels like a boundary, the edge of you, the place where the world outside begins and the self inside ends. It feels that way. It feels absolutely certain. But the electromagnetic field doesn't respect that boundary. It extends beyond your skin. The forces that generate the sensation of touch are acting at a distance, reaching out into the space around your body, interacting with other matter before any atom of yours gets close to any atom of theirs. In a physical sense, you interact with the world before you reach it. The you that feels things is built inside the nervous system, from data gathered by forces that never required contact. The brain constructs an experience of touch from electromagnetic signals, not from actual collision. The experience is generated inside you, based on what's happening outside you, mediated entirely by fields and particles that cross the gap without closing it. And this extends to every sense. Everything you've ever experienced, every color, every sound, every smell, every sensation is a model, a neural reconstruction, built from electromagnetic information about the world, processed and interpreted by the brain. You've never experienced the world directly, not once. You've experienced your brain's extraordinarily detailed model of the world, derived from electromagnetic data. The model is so good you've never had reason to question it. It's been accurate enough to keep you alive, to let you navigate, to let you connect with other people, to let you build civilizations. It's a remarkable model, one of the most sophisticated things in the known universe. But it is a model. The map is not the territory. And the gap between the map and the territory is where some of the deepest questions in science and philosophy live. So what are we left with? You are a collection of atoms, almost entirely empty space, held together by quantum rules and electromagnetic forces. When you interact with the world, your electron clouds and the world's electron clouds exchange virtual photons across a gap that never closes. Your nervous system translates that exchange into sensation. Your brain constructs an experience of touch, of solidity, of contact, experience that is completely real and completely valid, generated by a process that involves no contact whatsoever. The hardness of everything you've ever held, the warmth of every hand you've ever squeezed, the feeling of ground under your feet when you're exhausted and finally sit down, the texture of something you love to touch. None of it was physical contact. All of it was real. Here's what I keep coming back to. We have this picture, this intuitive, automatic, universal picture of a self moving through a world of objects, things out there, you in here, a clean line between them. And that picture is so deeply embedded in experience that it feels like the most obvious fact there is. The physics says the line isn't there. Your electromagnetic field extends into space around you. Other objects' fields extend toward you. The interaction begins before contact. The boundary of the self is not a physical edge. It's a region where interactions become dense enough to feel like a surface. There is no sharp line. There are only forces, and the experience those forces create. That doesn't make the experience less real. I want to be clear about that, because sometimes people hear this kind of thing and feel like they're being told the world is an illusion, that nothing matters, that physics has dissolved everything meaningful. That's not what I'm saying. I'm saying the opposite. The sensation of touching something is real. The feeling is real. The warmth of another person's hand against yours, that's real. That exchange of virtual photons between electron clouds is generating something genuine. The physics doesn't diminish that. It deepens it. Because somewhere between the virtual photon being exchanged between electron clouds and the felt sense of holding someone's hand, something subjective appears. Experience, qualia. The hard problem of consciousness showing up again the same way it did when we talked about life. We can trace every physical step in the process. We cannot find where the feeling enters. We cannot find where the quantum mechanics becomes the sensation. The map is exquisitely detailed. The gap between the map and the experience remains. What I find beautiful about all of this, and I mean genuinely beautiful, not consolation prize beautiful, is what it says about how far our brains have taken us from what they were built for. We evolved to track moving objects, recognize faces, navigate terrain. We were not built to think about virtual photons or probability clouds or the Pauli Exclusion Principle. Those concepts are nowhere in the ancestral environment that shaped our minds. And yet here we are, using these same brains, figuring out what touch actually is at the quantum level, finding out that solidity is electromagnetic, that matter is mostly empty, that the boundary between self and world is softer than anyone thought. And in finding all of that out, we didn't lose touch, we didn't lose warmth, we didn't lose connection. We just found out those things are stranger and more remarkable than we knew. You've been holding hands with people you love your whole life. And what was happening at the level of physics is that your electron clouds were exchanging virtual photons with theirs across a gap that never closed, following quantum rules that also hold up white dwarf stars. The Pauli Exclusion Principle was in the room with you. QED was in the room with you. The universe was that close. You have never touched anything. And yet every touch you've ever felt was the universe reaching across a quantum gap to tell you something was there. Both things are true. And the distance between them, the distance between the physics and the feeling, that's where the deepest questions live. Not just in physics, in everything.